In this video we're going to go over some of the important, or most of the important properties of exponents. Okay, so we have the product rule, and we have the quotient rule, we have the power rule. We got raising a product to a power, we got raising a quotient to a power. At this time you may want to pause the video and take a screenshot of these rules, or go Google them and print them off so you have them, so you can use them in any math course that you're in. Okay, so let's move this up and out of the way, and we'll go over each one of these rules. Okay, so let's go over the product rule. Now, it was written as a to the power of m times a to the power n equals a m plus n. So let's use real numbers and show that this is true. So let's just use something like this: 2 to the power of 2 times 2 to the power of 3. Okay, well, according to this rule, this should just be 2 to the power of 2 plus 3, right? Which equals 2 to the power of 5. Okay, now 2 to the power of 5, well, that can be rewritten as 2 times 2 times 2, sorry, times 2 times 2. Alright, 2 times 2 is 4, bring down this other 2, times 2 is 8, bring down this other 2, equals 16, bring down this last 2, oh, it's 16, not 10, and then that equals 32. So 2 to the power of 5 equals 32. Now, let's prove it this way as well. What's 2 squared? Well, that's 4. Alright, and 2 to the power of 3, well, that's 8. And what's 4 times 8? Well, that equals 32. So 32 equals 32. So we've just proven that this rule is accurate. Okay. All right. Let's make room, and we'll go over the other rules here. All right. Oops. So let's go over the quotient rule. Now the quotient rule is this: a to the power of m divided by a to the power of n, and this equals a m minus n. So a to the power of m minus n. Okay, so let's prove this out. Let's make sure that this works. Okay, so let's just use something simple again, like 2's. So let's say it's 2 to the power of 5, all right, divided by 2 to the power of 3. Okay, well, what does this equal then? Well, it's 2 to the power of 5 minus 3, or that equals 2 to the second power. Okay, well, what is this 2 to the second power? Well, that's 4. Okay, so we're saying that the final answer is 4. Well, let's double check this. What's 2 to the power of 5? Well, if you recall before, we found out that 2 to the power of 5 was 32. And what's 2 to the power of 3? Well, we know that's 2 times 2 times 2, which is 8. And what is 32 divided by 8? Well, that equals 4. So, again, they verify themselves. It's true. All right, so you can rewrite this as this, and then simplify it to that, and get this, or you could do it this way. But this rule is true then. Okay, so let's go over the next one, which is the power rule. All right, so what is the power rule? All right, the power rule is this. Okay, you have something like this. Okay, you have a to the m power, sorry, and then you're going to power that to the n power. All right, and what does that equal? Well, that equals let's use a different color. There we go. That equals a m times n. All right, well, let's verify that works. Okay, so here we go. Let's give it a try. So let's use something real simple here, like how about 2 to the power of 3, okay? All right, and then let's do that to the power of 2, okay? Well, according to this, it says that it's going to equal 2 to the power of 3 times 2, which simplifies to, oops, sorry about that, which simplifies to 2 to the power of 6. And 2 to the power of 5, if you remember correctly, that was 32, and then 2 to the power of 6 would be then just 32. Well, we can write it out, but we know that 2 to the power of 5 is 32, so then this is just times 2 again, so that equals 64, okay? So that's what this says it is, right, when we do it this way. So if we apply this rule and use it, then it equals 64. Well, let's verify. So let's verify by doing what we've done before. So what's 2 to the power of 3? Well, 2 to the power of 3 is 8, right? And then we square that, okay? And what does that equal? Well, that equals 64 as well. So this verifies, okay? You could use other numbers and it would still work. All right, let's go over raising a product to a power. So we're going to raise a product to a power, okay? What does that mean? So let's go over that. Let's use a different color. Let's use this one. So say we have a times b, all right? And we're going to raise that to the product of m, all right? I mean, not the product. We're going to raise that to the power of m. Sorry about that. So we have a product here, all right? The product is a multiplication, a times b, and we're raising it to the power of m, okay? And what will that equal? Well, let's use a different color again and play around with this. This one's that. All right, so according to this, it equals, oh, no, we don't want that color. According to this, it equals, no, it's too bright too. Let's try this one. This equals a to the power of m times b to the power of m. All right, well, let's verify that. Let's try this out. So let's see here. Let's do 2 times 3, okay? To the power of, let's just make it real simple. Let's do to the power of 3, okay? So make it even more simple than that. Let's do to the power of 2, okay? All right, according to this, it should equal this. 2 to the power of 2 times 3 to the power of 2, okay? And then if we go further, that's going to be 4 times 9, which equals 36. All right, well now let's do it. Let's do it this way first, and then let's do the multiplication first, and then let's power it. All right, so what is 2 times 3? Well, that is 6. And then if we square that, which we have here, what's 6 squared? Well, 6 squared is 36. So again, it verifies. This and this are equal to each other, so this is a true statement. Okay. All right, let's make some room. Okay, so let's go over some other examples. So here we go. Let's go over the rule, which is raising a quotient to a power. Okay, so quotient is basically a division. All right, so we had something like this: a divided by b to the power of m. Okay? And then that is supposed to equal a to the power of m divided by b to the power of m. Okay? So let's verify this. Let's make sure this is true too. So let's grab this and let's say that we have, how about we have 16? No. Let's use something a little bit easier. Let's use 8. 8 divided by 2, okay? And we're going to raise it to the power of 2 as well, okay? Alright, well then that means that this is 8 to the power of 2 divided by 2 to the power of 2, okay? And then if we do that, that's 64 divided by 4. And then after that, that's going to be, let's see here, 64 divided by 4. I think that's going to be 16. 16 is 4, yeah, it's going to be 16. Okay, so that's the answer. Well, let's verify that's true. Okay, by doing what's in the parentheses first and then squaring it. So what is, change the color. What's 8 divided by 2? Well, that's 4. Right? And then we're going to square that. And when we square that, what does that equal? Well, that equals 16. So again, these are equal to each other. So this rule is true. It holds true. The statement is true. So anyhow, that's it for right now. That is all of the properties of, those are all the properties of exponents that I want to go over. There's a couple more, but let's just stop there. And then maybe in another video we'll go over some more properties. All right, take care.